We were talking about magnetic fields yesterday, right? But we talked about how magnetic field affected the charges. So we talked about magnetic field acting on moving charges, right? We talked about it, like what happens when there's one charge, or we talked about what happens if there's a collection of charge. Now I want to talk about what happens when charges themselves start to move. And so I want to talk about magnetic fields created due to moving charges. So when charges move, they inevitably become sources of B fields. Okay, so the first person that observed it, his name was Hans Ørsted. In 1820, he was a Danish physicist and a chemist. He observed that a compass needle aligns along a circle when it is brought near a current carrying wire. That was the first link between electricity and magnetism. Okay, however, experiments are hard to perform. Why are they hard to perform? These are hard to perform because isolated moving charges do not make a current. So we have to resort to thought experiments. That include one moving charge. Otherwise, all experiments in reality are done with current carrying wires etc. Okay. So we are going to do our thought experiment, and we are going to give you the results of our thought experiment with one moving charge. Okay, number one. Field strength is proportional to the magnitude of velocity. Field strength is also proportional to the charge Q itself. So you can write this as V, the magnitude of velocity. Number two, if V reverses direction, B also reverses direction. If Q changes sign, B also reverses direction. So far, so good? Okay. Number three. B field is 0 for all points along the direction of R. And B field varies as sine of theta for all other directions relative to R. Number four. B is tangent to circles drawn about V in planes perpendicular to V. And the direction of B is determined by right-hand rule. On any given circle, the magnitude of B is equal. And B decreases as 1 over R squared, where R is the distance away from Q. Okay, start at number one and start combining everything. Okay, so number one says B field is proportional to V. 1B says B field is proportional to Q. Number 3 says B field varies as sine of theta. And number 4 says B decreases as 1 over r squared. Is that how I would write this? Give me a thumbs up if that all makes sense. Okay, perfect. Now, how do I get rid of the proportionality sign? I have to put a constant there, correct? And the constant is mu naught over 4 pi, where mu naught is the permeability constant, and numerically equal to 4 pi times 10 to the minus 7 Tesla m over A. And by the way, the relationship between mu naught and epsilon is this. Okay, but this is not the form that most textbooks write it as. What they write it as is this. This is called the vector form. V sine theta should somehow equal V cross R hat. Okay. What is R hat? Is R hat that? Is this statement true? What is the magnitude of R hat? 1? Okay, so I'm going to do some magic. So I'm looking at this part only. Ignore this part yet. Okay, pretend this doesn't exist yet. If I start from this side, actually, let me do that so it'll be easier for me to get rid of later. Okay, this is a cross product, correct? What do I know about the cross product? Magnitude of V, magnitude of R hat, and then sine of the angle between them. Is it not the same as V sine theta? Do you see how that worked? Okay. So that was good. Another way textbooks usually call this is B equals mu naught over 4 pi Q V cross R divided by R cubed. Now, for heaven's sake, how did I get that? So this is exactly how it went from one to the other. Because what is r hat if nothing other than r over the magnitude r? Right? You plug that in here and you get
R over R cubed.